cubes should be tied to its parent element. Like if you are taking 2 cubes for the columns, tie the cube to the column. And if you are taking cubes for the slab, tie it to the slab. And same beams. So that the amount of curing you do to the slab or column or beam will be applied to the cube also, and cube test result will reflect the curing also, so that we need not. I implement this in some of the projects. And mobile batching plants, we all know Ajax for convenient 4 cubic meters batching. And then transportation of concrete. Trolleys, first is head loads, transportation of cement and dumpers. And then we have tippers. We have the transit mixers, which is very common nowadays. And then we have these placing, next important thing. After transporting, placing of the concrete, we have manual placing and spreading, hoist placing, and then we have hoist bucket, and then we have the tilt bucket, and then boom placer. Boom placer is again becoming very common. One advantage of these machines is, earlier we used to find it very difficult to get a boom placer. But now boom placers are so many available in Hyderabad, we can use it for every application, particularly for column concreting. Boom placer is very advantageous. Next is the compaction, poking, and the compaction by ramming and tamping, and then vibrating. Main important thing, compaction for the slabs, the pan vibrator or the placer, the tamper is very important for slabs, which is not being used generally. So we have to insist on pan vibrator or plate vibrator for the slabs. Next is the finishing, manual trowel and power trowel, and then pavers. This is the word I missed actually. Paver also we can use it for slabs actually. You can put the vibrator to the paver and then compact the slab and level it also. Dimension tolerance, mainly we use it for pavements. These pavers, automatic pavers, and we can maintain the dimension tolerance in the pavers. Next is the setting time, initial setting time. We all know maximum, normal initial setting time is 30 minutes, but we can delay it by using the retarders. So we have to design the retarder, and I have many stories on the retarders also. Long back, about 25 years back, when ready-mix concrete was new, we had the concrete slab never setting after 48 hours also. Initial setting didn't happen. Then when we investigated, we found that the lorry, the transit mixer driver was given the retarder. He was asked to pour one batch, some quantity for every 1 hour. He doesn't have patience, so he put the whole quantity in the transit mixer in one go. And it happens even now. Recently also I had a problem in one of the sites where concrete didn't set for 24 hours. But this time it set, it is not because of the retarder, it is because of the cement quality itself. So we have these issues every day. The issues that we had 25 years back, today also we will have these issues. So we have to be, we cannot take anything for granted, whether it is cement, whether it is retarder, whether it is plasticizer, everything we have to be very cautious, we have to engineer and we have to control and we have to assure. Next, we got a normal test for the cement. We got apparatus, final setting time, and these are the plasticizers. Now, I just want to repeat, what is the lowest water cement ratio that we can use for the cement to set? This is very, very important thing. Nowadays, we are seeing precast concrete, hollow core, where the water cement ratio has to be maintained at 0.22. We have to understand what the lowest water cement ratio that is required for cement to set is 0.17 to 0.19, depending on the climate. And then next level is 0.22, and next level is the design, 0.3, 0.35, 0.4. But why we are not able to maintain this low water cement ratio is because of the workability. So for the workability, we are adding the plasticizer. Next is the retarder for delaying the initial setting time. And admixtures. Does it not remind us of again coffee? Nowadays, when you ask for a coffee, you'll ask for whether it is vanilla flavor or anything. We only knew coffee. Cement also has the flavors now. We have so many admixtures which we can use. And finally, curing. What is the curing period required for different elements? The curing period varies from various elements and the design mix also. And nowadays we have accelerated curing methods and also the centering, decentering methods, drop head system, drop in position system, and also the concrete is not in isolation that we decide about curing or decentering depending on the codal provisions. We have to design and engineer that. So poor concrete, we should be able to see the concrete surface and tell whether it is compacted or not, whether it is cured or not. By seeing the surface, we can tell. And curing by shading. Nowadays, we have the curing compounds also. Hyderabad Metro, we have seen how effectively they have used the curing compound. And then covering gunny bags. This is the best thing you can use for columns, particularly vertical surfaces. Sprinkling water, then ponding for the slabs, and steam curing. And then we have types of, another method of curing is heating heads. That is the latest thing for, we can heat the formwork so that is mostly helpful in cold countries, but in also precast we can use this curing head, the heating heads for the curing. So types of concrete now, how many types of concrete we can design? Mass concrete, greaseless concrete, precast concrete, and ready-mix concrete, pumped concrete, high-performance concrete, bendable concrete, roller compacted concrete, which is very, very important nowadays for the pavements actually, and pervious concrete and self-healing concrete, that is bacterial concrete, stamped concrete, and textured concrete, colored architectural concrete, glass concrete, asphalt, rubberized asphalt, and underwater concreting, fiber reinforced concrete, which is very, very, nowadays in fiber reinforcing itself we have so many variations, 10, 20 variations. Self-compacting concrete or flow mix nowadays, cold weathered concrete, hot weathered concrete, shotcrete, translucence. Shotcrete is another design mix that we have to do. And lightweight concrete, gypsum concrete, lime concrete, air entrained concrete, and waterproof concrete. Temperature controlled concrete and ternary blend concrete, GGBS slag based nowadays we are using, high volume fly ash concrete and silica fuel concrete, high density concrete and polymer concrete, and geopolymer concrete now it is gaining importance, pre-packed concrete, that is ready-mix. UltraTech is also selling that pre-packed concrete, floating concrete, reflecting concrete, sustainable concrete. Some of the photos I'll show. Mass concrete, pre-stressed, precast, and ready-mix concrete, and pumped concrete. And this is the high-performance concrete. You can see the thickness of the wall is 25 mm here. And this is the bendable concrete. This I have come across about 10 years back, 12 years back in the research stage. This photograph I have got. It rebounds actually, the elasticity of the concrete. You can see ductility. We think that concrete has no ductility. But the concrete can also absorb energy with this design. And rolled compacted concrete and porous concrete or permeable self-healing concrete. Self-healing concrete is used for repair of cracks in the concrete. And textured concrete, colored concrete, and glass concrete, asphalt concrete, and rubberized asphalt, underwater concreting. Underwater concreting is very important for offshore structure. And fiber reinforced concrete, bacterial concrete, self-compacting, and shotcrete. Shotcrete is very useful for tunnel works and granite concrete, and lightcrete and gypsum concrete for floorings and ceiling, lime concrete, cold weathered concrete, and hot weathered concrete. We design the concrete for temperature emission or this one. So tests, finally, slump test is very, very important. Nowadays we are missing actually. We are again taking it for granted. If it is RMC, it is taken care, but still RMC also we have to do the slump test and the bleeding test on the concrete, air content, setting time, segregation resistance, and unit weight, wet analysis, temperature, heat generation. And this is the slump test and compaction factor test and VB consistometer and bleeding test and air content test and vacuum dewatering concrete and the concrete repairs. Now we have talked about good concrete if you follow all the steps, but what if we come across bad concrete? We have to again repair it. So micro-concreting, bonding agents, shotcreting, gunneting and steel jacketing for repairs and concrete jacketing, grouting, repair, mortar, non-shrinking grout, pressure, and so these are all the unvibrated concretes that we may come across. The honeycombs, very bad concrete actually. And this is also, these are pictures from actual projects only I have taken, so let's not take anything for granted. The formwork design, formwork engineering has to be perfect and concreting has to be perfect. Time lag has to be maintained correctly. And cracked concrete, shrinkage concrete. Shrinkage is another most happening thing nowadays, we all know. Plastic shrinkage, dry shrinkage and all. So finally quality, prevention is better than cure. So let us follow the quality steps starting from mixed design to raw materials, storing, batching, transportation to site, actual construction, curing and maintenance, and cement quality, fineness, chemical composition, setting time, tensile strength, compressive strength, and free from injurious oils, free from water quality, acids, alkalis and organic materials. One answer to all this is fit for drinking. And storage of cement and concrete setting time, slump, workability, water cement ratio, and measurement, cement measured by weight, all by weight actually. We have to use concrete cube. Now I'm just giving the list of registers. This is as per the CVC norms. If you maintain these registers, you can do the quality checks audit very easily. So we follow these 22 registers. It is available in my website also, and I can share to anyone who wants it, these registers list and also the formats of these registers. If we maintain these formats, one time in one of the projects there was cracks in the slab after decentering. I was called to check and confirm what is the problem. Because of these registers, within 10 minutes I could fix the problem, what happened at the site. And then we could arrive at the solution. So it saves a lot of time in investigation. Like a good doctor, a good engineer can give a solution with these registers. So this is not my invention. It is actually, I am following for last 28 years. It helps every engineer very well if you follow these quality registers. In quality assurance and quality control and quality audit. Whenever I go to site, I make it a point, I sign these registers. If my engineers are not updating, I'll write you are not updated. That is my quality audit procedure. So every engineer, it protects engineers actually. It protects engineers if we follow this method. So I'm not explaining everything, but so this is the concrete pour cards for concrete, different pour cards at different levels, and method statements for every concrete work. Also we have developed. And it's all available in that SOP book that we have authored, which is available with Kerala, Telangana. Any engineer can get that. We documented all this in that. Method statements and test results of the materials and the other registers. And quality audit, plan, assure, control, and audit. So this is the quality steps. Third party vigilance enforcement. We have to avoid means we have to follow internally these things. And the CVC sign the registers, engineering saves engineers, and discipline the disciplines. So this is my final word. So thank you very much.
So that was a remarkable speech, sir. Thank you so much. Prati Amsani Kulanka Vivaristu, I think, abundant of knowledge ni ivala ma andarki provide chesaru. Thank you so much. Thank you. Ladies and gentlemen, put your hands together. సో